one mole amount of that particular element. So basically, mole is unit. So this is one thing how you can gather or how you can collect one mole amount of any particular element. The other definition of the mole is that the mole is the amount of substance of a system which contains as many elementary entities as there are atoms in 0.012 kilogram of carbon 12, and its symbol is molecule. Now, do not confuse it or do not worry that why we are only taking carbon. Carbon is taken here as a reference. You can take any other element, then you can take it. But the problem here would be the atomic mass of that particular element should be known. Like we know that the atomic mass of the carbon is 12 gram. So according to that, it is saying that 0.012 kilogram, because this is in kilogram, or you can say that 12 gram as well. So the meaning of this that if you take 12 gram of carbon 12 molecule or the element, you will have approximately 6.022 10 to the power 23 number of atoms present in that 12 gram amount of carbon 12. Similarly, if you take the same atomic mass of any other element, suppose you have hydrogen, you take 1 gram of the hydrogen. Hydrogen is a gas. So 1 gram of hydrogen will occupy more space, but here the amount would be same. 1 gram of hydrogen will also have the same number of molecules in it, some number of atoms in it. That is 6.022 10 to the power 23. So here carbon is taken as a reference for all the other elements. And if you take 0.012 kilogram of the carbon at one side of your weighing machine, suppose, and you take the same amount or the same equal substance of any other element which is having the equal amount of this carbon 12 gram, so that would be equal to 1 mole. So the mole is the amount of the substance which is present as many as elementary entities. Elementary entities are what? Elementary entities are these atoms, molecules, ions, or other whatever you are having. So the same number should be contained there, which is equals to the weight of 12 gram of the carbon 12. So that would be defined as a 1 mole amount. So either you can take as a weight or you can take as a number. So both would be the mole, 1 mole amount. You can take the number as well. You can take the weight as well. It is up to you. So mole is, this is how defined. Either that would containing the 6.022 10 to the power 23 molecules in it, or it is having the equal number of entities which is contained in 0.012 kilogram of carbon 12. So both are equal here, you can say, but one is defined in the reference of the carbon, another is defined in the exact number. Generally, how moles are calculated, suppose you have some amount of carbon 12 or some amount of any other elements. So how to calculate how many moles are present there? So to calculate it, there is a simple formula. If you want to know how many moles are present, mole is equals to weight of that particular element which you are having, maybe carbon, maybe hydrogen, whatever you are having, and just divide that number of the weight or the weight unit to the molecular weight of that element. For example, carbon 12, carbon 12, the weight you are having, suppose 12 gram, 12 gram of carbon 12 right now you are having at a particular this maybe a particular area you are having this. So, and you want to know how many moles of carbon are present there. So 12 grams the weight you are having and divided by the molecular weight of that particular element. That is again 12 grams, because we know the molecular weight or atomic mass of the carbon 12 is 12. So this would be equal to 1 mole. Same thing is defined in this definition as well. That is elementary entities which are present in 0.01 kilogram of carbon 12. For any other molecule element you want to calculate, so again take the weight of that element that you are having and divide it by the molecular weight of that. For example, let's see, suppose you are having helium. You are having 10 gram of helium, and we know that the molecular weight of helium is 2. So 10 divided by 2 grams. So this would be equals to 5 moles of helium. So this is how you can calculate the number of moles for any particular element. You don't need to count the numbers here. That's why this particular second definition is provided. So easily you can calculate the number of moles of any kind of element. So this is the concept of mole. I hope this is clear to you. So we can move ahead now. Now, another concept that we are going to discuss here is the molarity. There are two terms here. One is molarity. Molarity is denoted with the help of capital M. Then another term we have that is molality. Molality is defined in the terms of small m. So what is molarity? Molarity is again a unit. Unit to measure what? Unit to measure concentration of any particular solution. The same thing can be done with the help of molality as well, but both are different units. Now let's see molarity. Molarity is the numbers of moles present of any solute. Suppose you have salt solution in a glass or in a container. Suppose you are having water in it and you put salt in it. So now how to see what is the concentration of salt in this particular container, in this particular solution, because you have added the salt. So the different solutions will have different molarity because the amount of salt would be different in those solutions. So for the solution of that particular problem, we have introduced the concept of molarity and molality. So here what you have to do, you have to calculate the numbers of moles you have added of the solute, that would be salt here. This is your solute. This is your solvent. Solvent is your water here, which is present already in the container. And by the mixing of both, the new solution is coming out. So that is your solution. So solute, solvent, and solution. So the number of moles of solute, it means number of moles of salt you have added in the water divided by the pure volume of the solution, whatever volume it is creating right now. So that would be the volume of solution. Suppose you have added 2 moles of salt in it. So that is the double of the molecular weight of that salt divided by volume of solution. Suppose you have uh, created 1 liter solution. So here volume of solution you have to provide in liter. So 2 divided by 1, that would be 2 molar solution. So that is how you can calculate molarity of any particular solution. So that is molarity. Molarity means the number of moles of solute present in a solution divided by volume of that solution. How you can define the molality? Molality is again number of moles of solute. Again, you have added suppose 2 moles divided by this time you cannot take volume in the molality. It is defined this with the help of weight of the solution. So they divided by weight or mass of the solution in kg. So suppose it is having again 1 kg of the weight, so you will say that this is 2 molar solution, not molar solution. So if you are solving your solute by measuring the weight, so you will create molar solution. So you have to measure it with the help of molality. Then if you are creating the based on the volume of the solution, so you can measure the molarity of the solution or you will create molar solution. So this is the concept of molarity and molality. Hope this is clear to you. These are the very basic things. If you look at the past papers in the very previous year papers, like 2012, 2013, on those times, there are multiple questions you can find out in the catalyst book as well from the molarity concept and molality concept. So before moving ahead, let's see some questions of the molarity and molality and how you solve them. So they can ask you anything here. They can provide you the molarity. They can ask you the number of moles. They can provide you molality. They can ask the mass of solution. So based on any two information they will provide, another you have to calculate by your own, and that will be your answer. So let's see the example here that you can see in screen. It is saying that calculate molarity. Molarity means the capital M you have to calculate of 10 grams of the glucose in 500 ml of water. So before solving this question, you should know the formula of glucose, because here the requirement would be calculating the glucose molecular weight, because it is saying that 10 grams of glucose. So 10 grams of glucose. So if you want to calculate the number of moles of glucose, you should know the molecular weight of the glucose. Then only you can calculate the number of moles present in 10 grams of the glucose. So what is the formula of glucose? Glucose formula you can see here. It is C6H12O6. This is known as glucose. So let's calculate the molecular weight of the glucose. So the six number of carbons are present here. So 6 multiplied by 12. 12 is the molecular weight of carbon. Previously, we have seen in the examples as well. 12 gram is the weight of or the molecular weight of the carbon molecule. Then plus hydrogen, 12 hydrogens are present here. And we know that each hydrogen is having 1 gram of the mass, atomic mass. So 12 multiplied by 1. And then six number of oxygens are present. So oxygen's atomic number is 8, atomic mass is 16. Generally, atomic mass is double of atomic weight. There are exceptions also in the case of hydrogen. Hydrogen is having one atomic number and same one atomic mass. So there are exceptions. But generally atomic mass is double of the atomic number. So atomic number of oxygen is 8. 8 multiplied by 2 is 16 is the atomic weight of the oxygen. And there are total 6 oxygens present, so multiplied by 6. And then just add them. 12 multiplied by 6 plus 12 multiplied by 1 plus 16 multiplied by 6. This will be equal to 180. Now you are having the molecular weight of glucose, which is 180 gram. Now you can calculate the number of moles of this particular glucose. We have 10 grams of glucose. So 10 is the weight we are having. In the place of weight, we are putting 10. Divided by, we have calculated the molecular weight of glucose. So divided by the molecular weight. So 10 divided by 180, which is equals to 0.05. Just cancel, this is cancel. 1 divided by 18, to solve that, we will get 0.05 number of moles or 0.05 mole you can say. Then molarity you have to calculate. Molarity equals to the number of moles divided by the volume of solution. Volume of solution is provided here, that is 500 ml of water. So number of moles are 0.05 we have calculated, divided by volume of solution in liter. So we are having 500 ml. 500 ml is how much? Half liter of the water. So half liter is 0.5 liter. So 0.5 we are putting here. So this, if you can solve it, this is equals to 0.1 molar. So this is how you can solve the molarity question. How to calculate the molarity of any particular solution of any particular solute. So I think this is clear to you.